How are crystals formed? Crystals are formed through a natural process known as crystallization. Crystallization occurs when atoms, molecules, or ions arrange themselves in a highly ordered, repeating pattern to form a solid crystal structure. This process can take place in various environments, such as underground, in the Earth's crust, or even in laboratory settings. The formation of crystals begins with the presence of a mineral-rich solution or melt. This solution or melt contains dissolved substances, such as minerals, in a liquid state. As the temperature and pressure conditions change, the solution reaches a saturation point where it can no longer hold all the dissolved substances. At this point, the excess substances start to come together and form solid particles, which act as the building blocks of crystals. The particles then undergo a process called nucleation, where they gather and arrange themselves in a specific pattern. Nucleation is influenced by factors such as temperature, pressure, and the concentration of dissolved substances. Once the initial particles are formed, they attract and incorporate additional particles, growing larger and more complex over time. The growth of crystals can occur through various mechanisms. One common mechanism is called growth by solidification. This occurs when a melt or solution cools down, causing the particles to lose mobility and become fixed in their positions, resulting in the solidification of the crystal structure. Another mechanism is growth by precipitation. In this case, a dissolved substance in a solution is brought to a state of supersaturation, where the solution becomes unstable and cannot hold the substance in a dissolved state. As a result, the substance precipitates out of the solution and forms solid crystals. The growth of crystals can also be influenced by external factors such as the presence of impurities or the availability of space for expansion. These factors can affect the size, shape, and overall appearance of the crystals that form. Crystals can take various forms and structures depending on the specific arrangement of their atoms, molecules, or ions. Some crystals have well-defined geometric shapes with smooth faces and sharp edges, while others may exhibit irregular or complex shapes. The specific arrangement of particles in a crystal determines its properties, including its optical, electrical, and mechanical characteristics. Overall, the formation of crystals is a complex and fascinating process that occurs naturally in the Earth's crust and other environments. The unique structures and properties of crystals make them valuable in a wide range of applications, from jewelry and decorative objects to scientific and technological fields.